So let's talk about visibility, okay? So when I talk about visibility, let me increase a little brightness. Yeah. So what do you mean by visibility? Visibility is nothing but the clarity, the atmospheric clarity. So what you can see, what you cannot see, right? And obviously, so basically I would just say that it is nothing but atmospheric clarity. So how much can you see in front of you, and how is visibility really affected? Like for example, if you see in this picture, it's low visibility, right? So visibility could be affected by probably water droplets, right? It could be rain, it could be mist, it could be fog, it could also be solid particles like in haze, solid particles like after Diwali, how the visibility is in Delhi. It could also be sand, dust, or smoke. Now, sand would be there probably in areas where there are a lot of sand, like for example, Rajasthan side or maybe Saudi side, right? Then it can also be affected by, you could say, ice, crystals, hail, snow, etc. So, poor visibility is more common in stable conditions. Why stable? If anybody has seen my stability and instability video, so basically what happens in the stable, so for example, this is my land, right? In stable conditions, my particles will just stay here. If they're water particles, if they're sand, dust, whatever particle, they'll stay, they'll not move because it's stable, right? But in unstable, what happens? Now if this is my land, okay, now in unstable conditions, either the air will rise or the air will descend or the air will move left or right due to the winds. So now if there was these particles accumulated, but because if there are winds coming here or maybe because of convection or whatever reason, this air starts to rise, so this will clear this area, right? So visibility will improve. So very important. So the stable conditions has bad visibility because the particles stay there wherever they are, and in unstable conditions where the air is continuously moving, in that it is good visibility. Okay, now there are type of visibility reduction. So we have a lot of different things that contributes to the reduction of visibility. So one is haze, then there is fog, and then there is mist. Okay, so what is haze? Haze is caused by solid particles like sand. You've seen haze in Delhi also. There are dust storms as well sometimes. So dust, then there is smoke. Smoke is normally when there's any burning, or like for example in Diwali, the crackers, right? That leads to a lot of haze after. So there's a lower or upper limit to visibility in haze. There is no lower or upper visibility. ऐसा नहीं है कि इसके नीचे रिपोर्ट होगी या उसके ऊपर रिपोर्ट होगी. So there is no limit, but haze is normally not reported above 5,000 meters of visibility. तो उससे नीचे नीचे ही रिपोर्ट होगी. So if there is haze, it will be closer to the ground. Haze is normally not at higher levels, so it's not even reported at higher levels. Now what results, what causes fog? Fog is normally, everybody could guess it right, I'm sure, water droplets. Okay, so water droplets visibility is, in the case of fog, like you've seen in winters in Delhi, if somebody is from Delhi or from North India, then visibility is less than 1000, could be 0 meters, and if it's water droplet, obviously there is relative humidity, right? So it's close to almost 100% because it's all water droplets. So the point here to be noted is that visibility is less than 1000 meters. That is when you could say it's fog, or also could be 0. So it's between 1000 to 0. इसके बीच में होगी visibility when there is fog. And in this case, because it's water droplets, relative humidity is almost, or you could say close to 100%. So these are the points that are important and questions could be asked on it. Now when we talk about mist, mist is again water droplets, but these are smaller water droplets. So I would write small, small water droplets. Okay, so that causes mist. It's again water droplets, definitely. Here the relative humidity, because the water droplets are small, so it is more than 95%. 95 से 100% के बीच में है, but it is not as close as it was in case of fog. So fog, the relative humidity is almost 100%, like it's almost there. पूरा ही saturated air है, ठीक है. But in case of mist, it is more than 95%. It could be 100, it could be just 95, depends. And the visibility is between 1000 meters to 5000 meters in case of mist. So these are the differentiating categories that you could see, characteristics, sorry. So here, this is the characteristics of haze, then there is fog, and then there is mist. Okay, so I'll just draw you a table to make it even better so that we know. So we could say what is the descriptor? Okay, one is mist, the second is fog, and the third is haze. Okay, or I can actually change it because fog will have the least visibility. So let me do it in descending or ascending order, any way you want to look at it. So haze and fog. Okay, so what is the lower limit? So when I say lower limit, so in case of mist, the lower limit is 1000, or upper limit is 5000. तो 5000 से 1000 के बीच में if there is this reported, it will be mist, right? So less than 5000 and more than 1000 is mist, and in this case the relative humidity is 95%. Okay, when we talk about haze and we talk about fog, so for haze again it's close to 1000 and it's again not reported above 5000 meters. Okay, this is all in meters. So haze is also reported between that. Here is or more. Here because there is no water droplets as such, so you could say but that relative humidity could be 95%, but not really water droplets. Okay, so yeah, so this is not a very important point here. Now we talk about fog, it could be 0 and the maximum can be 1000 meters. So this is the most important part, and the relative humidity is obviously close to or almost equal to 100%. So these are the very important points, and these can also come in the question. Now obviously visibility is also affected by rain, right? So visibility, when I talk about visibility, it is also affected by rain. There is also something called as drizzle, which is like very little rain. Okay, so drizzle कब होती है? जब आपका रेन जो है उसका जो वाटर ड्रॉपलेट का जो डायामीटर है, it is 0.2 to 0.5 millimeter. Again a question that could come. And the visibility in drizzle is noted to be very poor, so 500 to 3000 meter. It's not a very good visibility, and this is in meters. When I talk about rain, the water droplet is a little bigger, so the diameter of the droplet would be 0.5 to 5.5, okay, millimeter, and the visibility is not good but better than drizzle. So it's from 3000 meters to 5000, or you could say 5500 meters, that is 5.5 kilometers. ठीक है, एंड अगर ये तो रेन के केस में हो गया, अगर मैं इसको थोड़ा सा और इफ आई से हैवी रेन, इन दैट केस माय विजिबिलिटी कैन ड्रॉप टू इवन 1000 meters. ठीक है, सो व्हाट इज इम्पॉर्टेंट हियर टू नोट इज, एक तो डायमीटर रेन का क्या है, हैवी रेन में विजिबिलिटी ये है, विजिबिलिटी इन द ड्रिजल इज वेरी पुअर, 500 तक इट कैन गो, and visibility in rain is like that. अगर heavy rain हो जाएगा तो this. So this is main important points for the visibility. Now when we talk about a visibility, there's one more thing that we would talk about. One is what measures visibility. This is the instrument. This instrument measures. So this is known as you could search it on transmissometer. So there are total 3 of them. So if this is the runway, for example, let me make it with the black color. So if this is the runway, okay, this is the whole runway. In that case, I'll divide the runway into 3 equal parts. So this will be my touchdown zone, this would be my mid zone, and this would be my end or stop end, it calls as stop end, okay, zone. So there would be 3 transmissometers. So there would be one here, and one here. So this would be in all these, and they would measure visibility in all the 3 segments of runway to give you the right picture. So when the visibility is reported, the RVR, like we've studied in the meta topic, please go through that and understand RVR completely, how it is reported, what is P, what is November, what is Papa, in that, right? So P, N and U, uniform. What does it mean? Please do refer to that video. So when the RVR is reported, there is a possibility that all these three would be reported or only one is reported. If all the three are reported, then all the three are relevant, and what becomes the limiting factor is the lowest value. ठीक है, the lowest value reported becomes the limiting factor. So if you can or cannot land, limiting factor for landing and take off both. तो अगर आप लैंड कर सकते हो नहीं कर सकते हो, डिपेंड्स ऑन द वैल्यूज दैट आर रिपोर्टेड. सो टच डाउन जोन, मिड जोन, एंड जोन. इफ ओनली वन इज रिपोर्टेड, द अदर्स आर नॉट रिपोर्टेड, देन इट्स फाइन. इफ द अदर्स आर रिपोर्टेड, देन एवरीथिंग हैज टू बी टेकन इनटू अकाउंट. ठीक है. नाउ इन दिस डायग्राम, इफ यू सी दिस वन आई हैव टेकन फ्यू. सो दिस इज नोन एज हॉरिजॉन्टल विजिबिलिटी, दिस इज नोन एज स्लांट विजिबिलिटी, वर्टिकल विजिबिलिटी. Okay, now very simple, and this is RVR. So I think it's very simple. There is nothing to explain here. All right. So the horizontal visibility is nothing but basically a horizontal distance either on ground or in air that an observer with a normal eyesight can recognize a dark spot. तो यहाँ से अगर मैं देख रही हूँ तो यहाँ पे अगर ये डार्क कलर का कोई ऑब्जेक्ट है, that I can see, कितनी दूर तक I can see that, how far I can see it, that will give me my visibility during the day, and this object would be lighted during the night to check the visibility, and how far can I see the lighted object will represent my visibility. Slant visibility is obviously this. So how slant you can see, so sometimes there are clouds under you but you can see it, slant visibility is better. Sometimes there are clouds ahead of you but vertical visibility is better, and I have explained vertical visibility in the META chapter as well. And when we talk about RVR, that is nothing but runway visual range. So now the runway visual range जो है, that starts from your threshold area which is 15 feet above runway. Okay, so this is your threshold. ठीक है, तो ये इतना पोर्शन 15 feet above the runway से लेकर whatever you can see in front of you, lighted objects during the night and dark objects during the day. Now one last important point before we go to fog is that RVR are reported below 1500, that we all know, since we have, I am assuming everybody has seen the METAR video. So RVR is reported in increments, very very important, in increments of 25 meter up to 200 meter. मतलब 25 देंगे, 50 meters होगा, 75, 100, 125, 150, 175 and 200. तो अप टू 200 मीटर्स 25 के इंक्रीमेंट में इट विल बी रिपोर्टेड. 200 मीटर के बाद इट विल बी 50 मीटर्स ऑफ इंक्रीमेंट अप टू 800 मीटर्स. तो अब कैसे रिपोर्ट होगा? 200 के बाद से 250, 300, 350, 400, ऐसे टिल 800. नाउ आफ्टर 800 विल बी 100 मीटर्स अप टू 1500, है ना. उसके ऊपर तो वैसे भी वी डोंट रिपोर्ट. तो 800 से 900, देन 1000 एंड सो ऑन टिल 1500 meters it will be reported. I hope this is clear, and this also comes in the question, so this is also very important. Now let's talk about fog, right, near the land. So this is basically formed from water droplets which is near the land, which reduces nothing but visibility, right, we just studied. Okay, now there are different types of fog, that is what we're going to talk about. So first we'll talk about the radiation fog, which we've already discussed in the climatology chapter. So radiation fog happens during the winter seasons. Okay, one, that it happens during the winter season in India, and the second is that it happens after the western disturbances have passed, after the WDs. So what WDs are, look at my climatology video. So after the WDs have passed, that is western disturbances, then it happens over land, right. Then it also happens mostly in the North India that we know of, right. For India we are talking about, we don't care about the world. So it happens at the night. So what really happens is, so basically if I draw it here, so if there's sun during the night, the sun is gone, so now the land starts to get colder, right. So the air in contact with the land also gets colder, and it saturates to a point that it starts to condense. So it basically goes below the dew point, and that is how the fog is formed. If there are clouds present, in that case the heat will be trapped, so the formation of radiation fog is less. If more clouds are there, maybe radiation fog won't happen. Okay, because for radiation fog to happen, there has to be cooling Okay, that is called as cooling at night, right? You must have heard of it. So at night the ground loses its heat by radiation. So the ground becomes cold, cools the air in contact with it. If this lowers the air temperature, it goes basically below the dew point, water vapor condenses at droplets and the fog is formed. So for the radiation fog to occur, there are certain conditions that we need. One, there can't be wind, right? Because if there is wind, the air will keep moving, then it won't cool down that much. So it has to be a clear sky. If there is a cloudy sky, like I just told you in this picture, so again the heat would be trapped and it won't be a lot of cooling that would happen. So clear sky is very, very important. Then the second thing is there has to be high relative humidity. So water has to be there for it to saturate, to reach that saturation. And maybe light wind is okay, that could act as a nuclei. So light wind of maybe you could say 2 to 8 knots is fine. This happens when it happens at night or early morning. This is what we know. So it happens either at night, okay, or you could say early morning. It happens during the winter season. It happens after the WDs have passed. It happens over land. In India, it's in North India, right? So these are all the points that you need to know. Now the next type of fog is advection fog. This we have not read about, so I'll explain the advection fog. So advection fog is a very different type of a fog, of course. So it is formed when there is a movement of warm air, warm and moist, moist and warm air over a cold surface. Unlike radiation fog, this can be over land and sea, water both. It can be during day or night. So radiation fog was only during night and only over land. However, advection fog can happen either over land or over sea. It can happen during the day or by night. So it is the moist and the warm air basically moving over a cold surface. So what do you think is required? One, you definitely need winds to move that air. So winds up to 15 knots you need, right? Then you also again need high relative humidity because you need the air to get saturated, and you need a colder surface, right? Cold surface, for which it would create that environment that the fog is formed. So this is how the advection, it's a movement of basically moist and warm air over cold surface. Because of the temperature difference, ये advection fog form होती है. इसी का just opposite is steam fog. Okay, I'll hear. So this is how steam fog looks like. Steam fog. You must have seen, if you've been to any mountain area where there's water body, you would have seen that this is how the fog looks, you know, when you observe really. So steam fog के case में basically it's normally near the Arctic. It is also known as Arctic smoke. It looks like smoke. It is near the colder areas, oversea. This is oversea in polar regions mostly, or like Greenland, Iceland, all of these. Okay, you can have examples like Greenland or Iceland. Okay, now of course this is also again by the movement of air. So it is caused by cold air over from a land mass moving over a warmer sea. So cold air from land mass moving over a warmer sea. उसमें उल्टा था ना, उसमें warm air was over a cold surface. इसमें cold air जो land से आ रही है, because अगर आप देखोगे polar regions में the land obviously cools faster over the sea. So sea is relatively warmer. So that cold air coming from the land moving over this warmer sea creates this effect of fog. Now there are another type of fogs. What do you think this looks like? It's a mountain and there's fog on the mountain. And how is it formed? It is known as we have understood, we've already read about orographic lifting. So this is orographic fog. Basically air being, you know, wind is coming, it is pushing the air up the mountains, it's getting colder, saturation is happening and the fog is formed. So it is also known as hill fog. Okay, so this is how it looks. So there are mountains, you could see there are mountains and there's fog on the top of it. It is because of the air. So the wind is coming, it leads to the movement of the humid air up the hill. So if there is a hill, so there is wind coming from this direction, so whatever air was here, it is being pushed up. It was warm, now as it's going up and up, it's getting colder and colder and getting saturated and saturated, and here then there is finally fog is formed. This is known as orographic fog. द लास्ट काइंड ऑफ फॉग इज द फ्रंटल फॉग. फ्रंटल फॉग नाम से पता चल रहा है कि फ्रंट्स की वजह से जो फॉग बनती है, राइट. सो द फ्रंटल फॉग इज फॉर्म्ड बिकॉज ऑफ द फ्रंट. सो इट हैपन्स इन वार्म फ्रंट एंड occluded front, not both occluded, I'll tell you. So occlusion वाले में बनता है. How does it form? So the main cause is precipitation that leads to, okay, wait, let me explain how it formed basically. So this is formed when the warm air is basically coming to the colder area, right? So what is warm front? Warm air approaching cold air, right? So what is warm front? Warm air approaching cold air mass. This is all air masses, air mass. So that is warm. So up here, because of the temperature difference, this is formed. This is the fog that is formed. So frontal fog occurs at warm front or occlusion. The main cause is precipitation, lowering the cloud base to the ground. तो ये जो clouds है ना, ये अब ठंडे हो रहे हैं, right? Because warm और cold air के पास आ रहा है. Cold is already dense. Warm is being forced to rise. मैं येलो से बनाती हूँ. सो व्हेन वार्म एयर इज फोर्स टू राइज, इट लीड्स टू प्रेसिपिटेशन. जब वो प्रेसिपिटेशन होता है, द क्लाउड्स बिकम लाइटर एंड लाइटर, द वाटर इज रिलीज, दे कम क्लोजर टू द ग्राउंड. So when they come closer to the ground now, after precipitation, which is that clouds are being forced now to the ground, so that results in the formation of fog. And already the ground is cold because there is cold air mass. Hot air तो ऊपर rise हो गई है ना. So ये अगर मेरा cold air mass था, hot air mass आ गया इधर से, that is warm front, it's approaching the cold air mass. This is cold, this is hot. Now this hot air would be forced to rise above the cold air, right? So it will come somewhere here. अब वो क्या होगा कि because of that there is precipitation. Now precipitation के बाद the clouds would be forced down to the ground. Already it's cold, so that is why the fog is now formed. So now these are the questions from IC Joshi on visibility and fog. You can take a screenshot, attempt these questions. Let me know if you have any doubts. So we're done with the chapter.